Welcome, Dr. Epic here. Welcome to the first module. And in this module, we're going to talk about archaeology. We're going to talk about the human past. We're going to talk about science with a capital S. And we're going to go off to the desert sands of ancient Egypt because we are going to talk about what is archaeology. Right up above me is an outline that will serve as a table of contents for your notes that are about to follow. I would highly recommend pausing the lecture and writing that down in your notes. And let's go ahead and jump right in. So what is archaeology? Now, in the Americanist tradition, in North America, traditionally, archaeology is considered to be one of the four subdivisions within anthropology. I mean, this is an anthropology course. And the other three subdivisions of anthropology are cultural anthropology, linguistics, and physical anthropology. However, if you view archaeology properly as a methodology, archaeology is, you can see it's in all caps, so you know that the following definition is important. Archaeology is the scientific methodology of studying the human past through the medium of the archaeological record. Archaeology is both a social science and in the histories. It's both at the same time. Archaeology is the scientific methodology that explores the human past through the medium of the archaeological record. So, all right, well then what then is the archaeological record? That right there, my friends, that is the archaeological record, that picture right there. What is that? That is actually structure M1415. It's a structure that I excavated years and years ago in Guatemala. It's a residence that was converted into an ancestor shrine. It's very interesting. That's the archaeological record. And when I studied structure M1415, I studied it not because I was particularly interested in structure M1415. I studied it because I was interested in the people that built and inhabited and used structure 1415. The archaeological record, as opposed to the historical record, the archaeological record consists of the remains of humanity's material culture and its resultant impact on the environment. All right, what is material culture? Material culture is all of the stuff that we make. Material culture is artifacts, ecofacts, architecture, features, and any significant material traces of past human presence on a natural and man-made landscape. Archaeology, this is important, archaeology does not study the archaeological record. Archaeology uses the archaeological record to study ancient human activity. Archaeologists study the past through the medium of the archaeological record. They don't study the archaeological record, that's not the point. And I'm going to make an analogy with physics and astronomy, and you see the Milky Way there on the left. Astronomers do not study light. They do not study radio waves. They do not study transmissions from space. What they do is they use these things. They use light to study how these cosmic bodies move through space. You know, I always screw this up. If the color of a star is slightly blue shifted, it's moving away from the Earth. If it's slightly red shifted, it's moving towards the Earth. I think that's how it goes. At any rate, astronomers are not particularly interested in the light itself. They're interested in using the light to study how the star is moving. Archaeology does the same thing. It's not particularly interested in buildings and artifacts and stuff. It's interested in using the stuff, using the ancient material culture, the remains of the ancient material culture, to study what human beings did in the past. Archaeology is primarily a methodology. It is a way of studying something. It is not necessarily an end unto itself. It's a way to ask questions about the ancient human past. So why even do it? Why ask questions about the ancient human past? Because we don't really know what the ancient human past was. Anatomically, modern humans, they first appear around 100,000 years ago. Yet writing itself, the written word, historical record, that doesn't really start until the year 6000 BC, and then in the Middle East. So for most of human history, for like 99% of the human past, this was completely unrecorded by any historian. 99.2% of the human occupation of the planet was never recorded. It is not in the historical record. And it cannot be accessed without recourse to archaeology. Archaeology does not exclusively study history, although archaeology may make use of the historical record. Archaeology studies the human past. So why should we study the human past? Because the human past is an undiscovered country. We don't really know what happened in the human past. Nobody ever wrote down 99% of the things that happened during the long human occupation of the planet. We don't know what happened there. We can only, from our modern perspective, we can only sort of gaze backwards and sort of reconstruct what happened. It's an undiscovered country. And even the things that we know historically, the historical record is inherently unreliable. And archaeology can serve to clarify, edit, or even substantially change our understanding of the historical record. So why we study the human past to know where we came from. We study the human past to know how we interacted with our planet. We study the human past to know, to some extent, where we're going. And when you view archaeology as a way to study the human past, as a way to look at this undiscovered country, then you realize that archaeology in and of itself does four things very, very well. One, it provides a chronology for the people without history. These are the people who never had a historian comment on anything they did, or they never possessed language, and they certainly may not have possessed the written word. And a lot of these people, and we'll meet some of these people in the modules to come, particularly a group of Native Americans on the Texas coast who may or may not have been cannibals. They probably were, but anyway. For one thing, it provides a chronology for the people without history. The people who either didn't have a written language, or the people who were unrecorded by the histories of their day. The second thing archaeology does very well is it provides an objective fact to correct a subjective historical record. History is inherently unreliable. It's written by people with biases. It's written by people trying to prove a thesis or establish a point. Accurately writing down the events as they occurred is not what they're interested in. And we'll meet this when we come to the ancient Roman city of Pompeii. This might kind of baffle you. It baffles most students that we have no firsthand accounts of the eruption of Vesuvius and the burial of this Roman city by anyone who was inside Pompeii itself. We only have a single account of the destruction of Pompeii, written years and years later by someone who was, I think 30 kilometers away. And it's written in a personal letter. And the point of that bit of history is Pliny the Younger is just basically explaining how his uncle died in the eruption. He's not interested in accurately writing down everything that happened. So we're going to check and see, what is the archaeology about Pompeii? Does it support, modify, or reject the historical record about Pompeii? The third thing that archaeology does very well is that it reconstructs ancient life paths, how individuals in the remote past actually interacted with their environment, how they engaged in a long-term sustainable relationship with that physical environment, and how that relationship can go very, very wrong over time. We're going to examine two cultures that were able to build and maintain a sustainable relationship with the environment until they weren't able to do it anymore, and their civilizations collapsed, their societies collapsed. This third thing is what tends to be called human ecology or cultural ecology, but we'll visit that 8 or 9 modules down the road. The fourth thing that archaeology does very well is it provides a perspective into potential patterns of long-term human occupation and cultural variation through time. This is what used to be called sociocultural evolution. But sociocultural evolution has kind of had a battered reputation in the 20th century. And most people don't discount it, although archaeology is the only way to take these kind of long-range perspectives of the human occupation of the planet really well. The course is going to use 3 textbooks. And here they are, all around me, all around my little yellow box. I strongly urge you to get these textbooks as soon as possible. They include Archaeology for Dummies. I'm not saying anyone there is a dummy, but bizarrely enough, that's probably the best basic textbook in archaeology. And it's inexpensive, and it's the best written. It's a very, very good book. And then we're looking at 2 case studies right up above me. Rubbish by William Rathje, The Archaeology of Garbage. That is the archaeology of modern American society. And then from modern American society, we're going to go deep into the ancient past, looking at Arthur Demarest's Ancient Maya, The Rise and Fall of a Rainforest Civilization. And clockwise is the order in which we will read them. Nancy White's book first, William Rathje's book second, Arthur Demarest's book third. So we study the human past to do these 4 things. We study the human past in order to record the people without history. We study the human past so that an objective archaeology can correct a subjective history. We study archaeology in order to understand how people interact with their environment. We study archaeology to get perspectives on the long-term human occupation of the planet. And the first place we're going to do this, we're not going to start small in this class. We're going to go right for the biggest and the most impressive things in all of archaeology. We are going to ancient Egypt. We are going to tackle the question, who built the Great Pyramids of Egypt? And there they are, the Great Pyramids of Egypt, right up above me. All archaeology starts with a question. And we'll get in depth with the question we're going to answer in a bit, but we're actually going to talk about who built the Great Pyramids of Egypt and the archaeology around the pyramids and different theories that people have proposed about the pyramids, some very respectable, some from history, and some from outer space itself. But to answer these questions, archaeology is a scientific methodology, which means that it has to make use of the scientific method. There's the scientific method, straight from 11th grade biology, right up above me. And let's just review it real quick. Like, what exactly is the scientific method? The scientific method is this. 1, you formulate a hypothesis. 2, you develop a methodology to answer the hypothesis. 3, you apply the methodology. In this case, we apply the methodology to the archaeological record. And 4, you publish those results in a timely manner. That's one of the big differences between just messing around and science. Science publishes. So I'll just give you a run through. I get in my car this morning and I get in my Thunderbird and I stick the key in my Thunderbird and I turn the ignition and the car does not start. All right. I'm going to formulate a hypothesis about why my car does not start. And my hypothesis is that I have somehow displeased the machine spirit of my Ford. And in order for the car to start, I must placate the machine spirit that lives within my car. So I get out of my car, I decide I have to sacrifice a chicken to my machine spirit. I get a chicken, I sacrifice the chicken on the hood of the Ford Thunderbird. I pray to the machine spirit. That's developing and applying my hypothesis. And then I test my hypothesis. I get in my car and I turn the ignition. Nothing happens. So my hypothesis is flawed. I've tested the hypothesis that I've displeased the machine spirit of the Ford Thunderbird and arrived at the conclusion that sacrificing a chicken had no impact on the performance of the vehicle. I'm now going to come up with a second hypothesis. My hypothesis is I have a dead battery. All right? Now I have to develop a methodology to test this hypothesis. Okay. If my battery is still good, my headlights should come on. Okay? If my battery is bad, then my headlights won't even turn on, or they'll turn on just for a second. So I stick the key in the ignition, I activate the car, and I turn on the headlights. And the headlights, I'm testing the hypothesis. The headlights come on for a second and then fade away. Aha! That confirms my hypothesis. The vehicle has a dead battery, and I got to jump my Thunderbird. I had an old Thunderbird and had to jump it a lot. And then I publish the results. That's I don't know if a scientific journal would take a paper on dead batteries versus dead chickens, but it would be a worthwhile experiment. And this is something that is very important in a scientific method. It's not just that you develop and test hypotheses, but you have to have multiple hypotheses running at any given time. That you possess multiple hypotheses, sacrificing chickens to machine spirits on one side, testing your battery to see if it's alive on the other. But we're going to test multiple hypotheses not on a battered old Thunderbird, but we're going to apply these philosophies to recent archaeological evidence from the Giza Plateau of ancient Egypt. And this is a point that was made by probably one of the great scientific writers of the 20th century, a guy called Carl Sagan, if you've never heard of him. And there's Carl Sagan right up above me, rocking a burgundy turtleneck the way few men could rock burgundy turtlenecks. And one of the things Carl Sagan wrote is to think scientifically involves not just testing hypotheses, but it involves testing multiple hypotheses. You don't just create one idea and then test it. You create 2 or 3 or 4 ideas and test them all. And one of the most important hypotheses you can create is something called a null hypothesis that we'll meet later. It's a null hypothesis that says all existing hypotheses are incorrect. So you develop your methodology, you develop your hypotheses, you test your hypotheses, and your hypotheses will either do one of 3 things. Your test will either uphold your hypothesis, it will falsify your hypothesis, or it will modify your hypothesis. And then you have to test again over time. And one of the most important tools when you have different hypotheses, and evidence could support multiple hypotheses. And the way to pick between your multiple hypotheses and the available evidence is through the use of Occam's Razor. There is a photograph of a straight razor right up above me, and there's the definition for Occam's Razor on the left. And look, the definition for Occam's Razor is in all caps. That means it must be important. So what is Occam's Razor? Occam's Razor is a term, it's also called the law of parsimony or the law of the simplest. In Latin, it is pronounced pluritatis non est podenta sin necessitate. And I'm absolutely sure I mispronounced that. But basically, the law of parsimony, Occam's Razor, says that it is the simplest explanation that is the most likely explanation. So when you have evidence that supports multiple hypotheses, it is the simplest hypothesis that is the most likely to be correct. The more complicated hypothesis is almost always incorrect. So we're developing our thought tools. We have the scientific method. We have the idea that you must have multiple hypotheses. We have Occam's Razor. And now we're going to apply this to the archaeological evidence from the Giza Plateau, from the Great Pyramids of Giza. And there's a map of the Giza Complex right there to the left. So first off, what are the pyramids of Egypt? You see them all the time. They're in movies, they're in documentaries, they're all over the place. So what are the Great Pyramids of Egypt? The Great Pyramids of Egypt are generally the 3 main structures located inside the Giza Complex. And it's important to remember that the Giza Complex, the 3 Great Pyramids, are not alone on the landscape. There's all this stuff around the 3 Great Pyramids. They're not all by themselves, like way out in the desert. So it's important to note that the 3 Great Pyramids of Egypt are also the 3 Great Pyramids of Giza. They do not occur by themselves on the landscape, but are surrounded by a large number of funerary structures, temples, boat pits, smaller pyramids, cemeteries, and a large number of things that we'll meet later called mastabas. So stick a pin in the idea of the mastaba. We're going to meet him later. And all of these things are this large complex, and this complex is a necropolis. And a necropolis is a large ritual complex dedicated to the housing and veneration of the dead. There's a map of the Giza necropolis. And the important thing about a necropolis is like nobody lived there. Like the Great Pyramids of Egypt were never built like inside of a major city. They were always in a necropolis out in the desert, but surrounded by these hundreds of other features. Now the Giza necropolis has the 3 Great Pyramids, but it also contains a large number of other things. I mean, if you look at that map on the lower left, there's lots and lots of things inside the Giza complex. They're definitely not alone on the landscape. And the pyramids, there's an old photograph of the Giza complex. Most of the Giza complex was buried for most of its history. And the pyramids themselves have always stuck out. The 3 Great Pyramids have fascinated scholars for centuries, particularly scholars of the European Enlightenment, who originally thought they were giant monuments dedicated to mathematical concepts, because the dimensions of the pyramids are like absolutely precise. They are precise in a way that actually is going to cause problems later on. And there are things inside the pyramids. They're not these monuments to math, monuments to the Pythagorean theorem. But they contain chambers and passages inside the pyramids themselves. And there is the mapped interior of one of the Giza pyramids. We live in wonderful times. We live in a fascinating 21st century future where you can get on a computer and you can type in the Great Pyramids of Egypt and you can look at the pyramids from space. And that's what we're looking at right here. This is the 3 Great Pyramids of Giza as taken by a satellite. So you don't have to take that map's word for it. You can just look. There are the 3 Great Pyramids, and you can see they're surrounded by all this stuff. You can make out the Western Cemetery. You can make out the Eastern Cemetery. If you've got really keen eyes, you can actually even make out the Sphinx right about there. I think that's him, right about there. But one of the other misconceptions about the pyramids is that they are like way out into the desert. Originally they were back, in the Old Kingdom, but they're not anymore. Because if you look at the satellite image, you can clearly see the edge of the modern city of Cairo right up there on the right. That is the modern city of Cairo, and it actually has encroached on the edges of the old Giza complex. So, when you see these movies and people are like riding towards the pyramids and it looks like they're in the middle of the desert, that's actually not true at all. This is a photograph of basically the Great Pyramids from Cairo itself. The modern city of Cairo basically goes right up to the edges of the pyramids, right up to the edge of the Giza complex. And in fact, I had a friend who visited the Giza complex, and she wrote that like she went expecting to have this like epiphany and to be like completely awed by the spectacle and architecture of the pyramids. And instead, you have all this air pollution and you're standing looking at the pyramids and you can hear like buses honking their horns and taxi drivers yelling at each other like right over your shoulder. Because the pyramids are not like way out into the desert anymore. They're right at the edge of a modern city. And what I'm about to show you next is either incredibly sad or really kind of interesting or really kind of cool, depending on your opinion of pizza, because there's a Pizza Hut right next to the pyramids. These are photographs I've taken from people's tourist blogs. That you can sit in the Pizza Hut and look at the pyramids. They're right there. Also Kentucky Fried Chicken is right there next to the pyramids. And there's an Irish tourist who really, really needs to invest in sunblock. So this is either kind of a sad measure of 21st century, or it's really kind of cool. Again, depending on whether you like Pizza Hut or not. So who actually built these things? These things are not monuments to math. They're not. So what exactly are the pyramids? And who exactly built the pyramids? We're going to look at multiple hypotheses about who built the pyramids. Space aliens? Cosmic Atlanteans? Slaves. That's what most people say. And there's a comic book about the construction of the pyramids, the cruel overseer and his whip. There is no mercy for a slave of the state. Let these pyramids be a monument to your misery. Psh, whipping him. So what we're going to do is we're going to actually look at who built the pyramids using our thought tools, using Occam's Razor, using the scientific method, using the concept of multiple hypotheses. And we're going to use our thought tools and archaeology itself to answer a single big question about the pyramids. And there's the question right there. And the question is, who built the pyramids of Egypt? Evaluate the three hypotheses given about the construction of the Great Pyramids of Giza. Which is the simplest and therefore the most likely? Which is the least likely? What is supported by the current archaeological evidence? And we're going to use archaeology to solve this mystery about the ancient human past. And that's what archaeology is for. And that's why it's done, and that's how it's done. And we're actually going to approach this question and talk about the hypotheses about the pyramids next time. And I will see you there.